ME 8351 Manufacturing Technology 1, 4th unit, sheet metal process. In that 4th unit, we are going to see the stretch forming operations, formability of sheet metal, formability test methods, and special forming processes. First, stretch forming operations. Stretching is the process of stressing the work blank behind its elastic limit by moving a form block towards the blank or sheet metal. This is the process of giving the force to the blank which is behind the elastic limit by moving the blocks towards the blank, that is the workpiece. The form block has projections of extra size required on the blank, which is in the form of depression on the same blank. Stretching is mainly done for straightening a part to obtain a straight axis and uniform cross section. During stretching the blank, the spring back occurs after completing the stretching process. Now see the spring back. Spring back is defined as the movement of the metal to resume its original position, causing a decrease in the bent angle after the applied force is withdrawn. The spring back has to be considered to obtain the exact shape and size of the blank after the stretching process. This spring back is always depends on material type, thickness of the blank, hardness of the blank, and the bend to radius. The spring back generally larger bend radius produces greater spring back on the blank. Now, what are the things to avoid this spring back? Are overstretching using V-type form blocks, and the second thing is by coining the metal slightly at the corners of the blank to remove the elastic stresses called corner setting. And next one is the method of stretch forming. There are two types of stretch forming methods. First one is the form block method, and the second one is the matting die method. Let's see one by one. First, form block method. The working of the form block methods is the two end of the blanks or sheet metal is tightly held by an adjustable gripper. Let's see the diagram to understand the better concept. Yeah, this is the picture of the form block methods. Here is the form block which is operated by the hydraulic cylinders. It is an inlet and outlet wall. Above is a blank. The blank is fixed at the two corners. It is a adjustable fixing point. The two ends of the blanks is tightly held by an adjustable gripper. These grippers are fixed but adjustable. Then the form block is moved towards the blank to make the required shape by giving the hydraulic force. In this case, form block is operated by the hydraulic cylinder. When the block moves towards the blank, the hydraulic fluid inside the cylinder gets compressed and delivered to the outlet wall. The movement of the form always depends by the hydraulic fluid fluid pressure inside the cylinder. The fluid is entered the cylinder when the form blocks moves away from the blank after completing the stretching process. It's a single stretching process. We can get no need of stages in the stretching. Here, how much of force is needed for stretching process? By calculating which type of material and hydraulic oils conditions, the force is equal to pi by 4 and the piston diameter, square of the piston diameter into the hydraulic fluid pressure. The formula is F is equal to pi by 4 into d square into hydraulic fluid pressure. It's a single stretching process. Now, in the stretching method, let's see the right side diagram. It's a stretch forming. The same operations, the stretch forming methods. Stretching the blank can also be done by fixing the form block stationary and moving the grippers towards the form block. It is performed by holding the blank ends in movable grippers. It is a vice versa of the form block method. Here, fixing the form block stationary and moving the grippers towards the form block is a simple difference between the form block method and stretch forming methods. In the first case, form block method, it's a movable form block and adjustable grippers. The force is given to the form block, and the right side diagram shows the stretch forming operations. Here is fixing the form block stationary, which is not movable, and the force is given to the stretch force is given to the grippers, which moves towards the form block to obtain the required shape. Both the operations having a single stretching process. And the next method is the matting die method. In stretching operation, first of all we see the form block method. In the form block method, there is two types. One is the form block, and another thing is the stretch forming methods. And second type is the matting die method. Let's see the picture. Yeah, this is the calculation for giving the force. F is equal to pi by 4 d square into p. How much of hydraulic force is given to the form block. Next, matting die. This is the matting die method of stretch forming. Here is it's a diagram. Diagram A, work blank with respect to the tension, and the second thing is the movement of the upper die towards downward. Let's see the operation of the matting die methods. The blank is held in the movable grippers. The blank is placed between the lower and the upper die. The lower die is kept stationary and the upper die is movable, one which is operated by hydraulic or pneumatic cylinder. If I see the upper die and lower die setups. In between the blank, it's a sheet metal is placed between the upper and lower die with the help of the movable grippers. The blank is held in the movable grippers. Here the lower die is kept stationary and the upper die is movable. The movable upper die is which is operated by the hydraulic or pneumatic forces. First, the movable grippers are moved towards the lower die on which only elastic deformation takes place. During working condition, by using the movable grippers, the blank is firstly move the blank towards the lower die by using the grippers, and the upper die is moved towards the blank by using the hydraulic or pneumatic forces. The arrow mark show the how the upper die is in the direction of the upper die is movement and the gripper movement. When the upper die touches the blank, only elastic change take place. Due to the continuous touching of the blank by the upper die, plastic flow of sheet metal takes place between the lower and the upper die. When the upper die edges reaches the top surface of the blank, the stretching process is completed. Once giving the hydraulic pressure to the upper die, first when it touches the blank, only the elastic changes takes place. Due to the continuous forces of the upper die or continuous touching of the blank by the upper die, the plastic flow of sheet metal take place. Is the plastic flow means the changes takes place in the blank, that is sheet metal, between the lower and the upper die. Once the upper die reaches the top surface of the blank, the stretching process is completed. It is a single stretching operations. The shape of the upper and lower die are made the exact required shape of the sheet metal product. Exact shape of the sheet metal product. It's also the forming methods, also the type of the forming methods by using the stretching force. And the second right side diagram show the final workpiece. And the next thing is, what are the materials for die and the form blocks are wood, zinc alloy and cast irons. Based on the sheet metal material conditions, what are the advantages of the stretch forming operations? This is the matting die methods. It is a working principle, the diagram of the matting die methods. The next one is the advantages. What are the various advantages? The first main advantage is the in stretch forming operation is stretched in a single operation. Spring back is reduced when the compared to the other forming methods. In stretch forming operations, the spring back is reduced when compared to the other forming methods. Later we will discuss about the what are the various other forming methods in the end of this video lecture. And then next advantage is the direct bending is not introduced. The plastic deformation is due to pure tension only. No need to hitting the object or a repeated process. Only the tension, purely the tension gives the shape of the sheet metal. Here the tooling cost is very low. These types of stretching process methods is suitable for low volume production. These are all the advantages. And stretch forming operations having some disadvantages. The blank thickness should be uniform throughout the length. Yeah, thin sections are to be overstretched. That's why the thickness should be uniform throughout the length. Yeah, the sheet metal having the variable thickness throughout the blank, it gives the improper function. Next thing is the sudden changes in counter surface cannot be stretched. Yeah, yeah, sharp corners, sudden changes that cannot be obtained in the stretch forming operation. The maintenance cost of hydraulic cylinder is too high. And next one is the next one disadvantages is the process requires high quality form blocks. Yeah, the form blocks are needed. The form blocks made up of exact shape and size of the required object. And what are the limitations? Uneven thickness of the blank cannot be stretched. Stretching of blank to the required shape of counter is limited. The various applications of stretch formings are production of aircraft wings and fuselage parts, production of contoured panels for trucks, trailers, and bus bodies in the automobile industries. These are all the stretch forming applications. There are also many other applications in the stretch forming operations. Next thing what we see means yeah, next topics, fourth unit, next topic is the formability of sheet metal. Formability of sheet metal may be defined as the easy with which material may be forced into a permanent change of shape. It is a formability. The material may be forced into the permanent change of shape. It's a formability. The formability of the material depends on several factors. The important one corners with the properties of the materials like yield strength, strain hardening rate, ductility. These are greatly temperature dependent. As the temperature of the material is increased, the yield strength and the rate of the strain hardening progressively reduced and the ductility increases. The important factors of the formability materials are the yield strength, strain hardening rate, ductility. These are all temperature dependent one. As the temperature increased, the yield strength and strain rate are progressively reduced and ductility is increases. The hard working of the metal before permits relatively very large amount of deformation before cracking. Let's see the formability loss and formability test method. This is the detailed definitions for formability of sheet metal. It's mainly dependent on the behavior of material variable and process variable. So we can simply say the formability of sheet metal is the function of the material variable and the process variable. The sheet metal is specified in terms of gauges and mechanical properties. The behavior of sheet metal may be altered in actual working condition. The behavior is changed due to the working condition of the sheet metal. The two main things are important. The first one is the material variable and the second one is the process variables. That's why the formability is equal to, it depends upon the formability depends upon the formability of sheet metal is a function of the material variable and the simply the process variables. F is equal to F1 into F1 comma F2. First, material variable are nothing but the basic variable that governing ductility of the material. And the material variables are only in the ductility of the material. The process variable are applied stress systems, interface friction, lubrication at the interface, die design, production shape, etc. These are all the process variables. Now we are already know the formability of sheet metal. It's mainly dependent upon the material process and the material variable and process variables. In material variables only the ductility of the material, and second thing is the process variable or applied stress system, interface friction, lubrication at the interface, die design and production shape. These are all the consideration for the process variables. We give the few universal laws for which govern the material properties and the process variables. The law 1 gives the process of fracturing. For material variables, the ductility of the same material is lower if the section size is larger. And the second law is law of geometrical similitude. Blank are geometrically similar in all aspects with respect to the another blank, such as dimension, thickness, width, length, etc. All the aspects of dimensions, thickness, width and length are similar. Then these geometrical similar blanks should be fabricated by using the similar tools. And unit strain at corresponding locations are identical for geometrical similar blanks. The forces required to form any required shape on a geometrical similar blank are directly proportional to the square of the thickness. You want to get the geometrical similar blank which are directly proportional to the square of the thickness. The conception of the work for forming the required shape is also proportional to the cube of its thickness for geometrically similar blanks. These are all the laws for formability of sheet metal. And the next thing we are going to see about the what are the formability test method. There are many types. First one is the formability test for bulk deformation, formability test for elastic plastic deformation, simulative test for forming operations, and the final one is the full scale forming test. By additional to the forming test are hardness test, hydraulic bulge testing, biaxial stretch testing, uniaxial tensile testing. Those are all the various types of test in the formability of sheet metal. Let's see one by one. The diagram shows the what are the various tests in the formability of sheet metal. First one is the uniaxial tensile strength. The second thing is the biaxial tensile strength. Tensile strength in the biaxial direction. The first one in the uniaxial tensile strength, and a punch test on the specimen. the hydraulic bulge test, and Olsen and Ericsson cup test. Bulge test results on the sheet metals. Let's see one by one. Simulative test. Let's see the various tests in the formability of sheet metal. Let's see one by one. The first test is the formability test for bulk deformation. In this test, bulk deformation refers the deformation of sheet metal due to the both elastic and plastic deformation. The elastic and plastic deformation is always then 0.2. It's a ratio of elastic and plastic deformation is 0.2. For formability test for the bulk deformation, it purely based on the elastic deformation by the plastic deformation. The next thing is the formability test for elastic plastic deformation. In this concept, the three various tests show the elastic plastic deformation concept. First one is the test method based on tensile test. The second is the simulative drawing test, and the third one is the full scale forming test. Let's see one by one. These three tests are shows the elastic plastic deformation of the formability of the sheet metal. The first test is the test method based on the tensile stress. In tensile stress, the tensile stress for stretch forming operation and the tensile stress for drawing operation. There are two categories in the tensile stress method, for stretch forming operation and for drawing operation. First, in the stretch forming, tensile stress for stretch forming operations. Tensile stress for stress forming operation. Fracture of sheet metal is predicted by local thinning. At the same time, failure is avoided. The important property of work hardening is predicted in terms of stress strain. In this test, the fracture is predicted by local thinning by using the stress strain concept. Here is the stress is equal to A into strain power n, and here A and n are constant. E is strain, F is the stress. In generally, the friction between the blank and the tool is high, the critical zone will be restricted. The value of n varies from 0.22 to 0.24. And the next one in the test based on tensile stress is tensile stress for drawing operations. The sheet metal is deformed in the lower punch by thinning under biaxial stress. Then the average value of the sheet metal radius is determined by orienting the axis of metal flow at 0 degree at 45 degree. Determining by orienting the axis of metal flow at 0 degree at 45 degree and 90 degree. The mean value of radius rm is equal to 1 by 4 square root of radius at 0 degree plus twice the radius at 45 degree plus radius at 90 degree. Once again, the mean value radius rm is equal to 1 by 4 square root of radius at 0 degree plus twice the radius at 45 degree plus radius at 90 degree. Here, higher value of mean value of radius rm indicates good dryability, which varies from 1 to 1.7. And the next one is the simulative test. This is the simulative test. This test is conducted in various cup forming operations: erosion test, Olsen test, surfeit test, Fuchs test. First, let's see the erosion test. The standard specimen of 90 mm wide is clamped rigidly against a die having 27 mm diameter opening. A spherical punch of 20 mm dia is moved against the sheet metal. The movement of the punch continues until the fracture starts. At fracture, the bulge forms. The depth of the bulge gives the erection number. This value is very small in assessing dryability. The erection number, this value is very small in assessing dryability. The test is mainly carried in assessing stretchability of the sheet metal. So, erection test for standard specimen of 90 mm wide, it is clamped rigidly against the die having the 27 mm diameter opening. Specimen of 90 mm and the die having 27 mm die opening and the punch having 20 mm diameter, which is moved against the setup is moved against the sheet metal. The movement of the punch continues until the fracture start. At the fracture, the bulge forms. This is the example for the setup to identify the erosion test number for dryability conditions. And the next test is the erosion. We'll see the erosion test and the Olsen test. In similar to the erosion test, Olsen test, this test is slightly varies from the erosion test. The size of the standard specimen and the test are taken at the same mentioned in the erosion test, but the die opening size of the 50 mm diameter is used. But in the erosion test, the die opening is the 27 mm diameter. Here is the die opening is the 50 mm diameter. The remaining things are common, which is the specimen is 90 mm wide, which is clamped rigidly against the die having the here the 50 mm diameter and the punch having the 20 mm diameter. Here in erosion test, the sheet metal, the specimen is fixed rigidly. In Olsen test, the specimen is clamped lightly. The bulge and the fracture are formed due to the stretching only when the punch presses the sheet metal. This test is also carried out for assessing stretchability. First, in erosion test, these types of conditions and punch die, punch size, die opening size and sheet metal size, these are all give to find out the assessing stretchability of sheet metal. Aeration test is mainly for accessibility of stretching the sheet metal. The Olsen's test carried out for assessing the stretchability. These are all also same to find out the stretchability of the sheet metal. And the next test is the shift test. The flat bottom mid cup of uniform diameter are formed from a series of metallic sheet blank, but these metallic blanks are different diameters. This process is continued until the blank size is found, which all cups fracture. The LD or the limiting drawing ratio, which is blank dia, it's a ratio of the blank diameter by punch diameter. The shift test is mainly for assessing the dryability of the sheet metal. The main disadvantages of the test is the edge wrinkling due to the lightly clamped blanks. It is the shift test is for obtaining the to find the dryability of the sheet metal in the working condition. And the next test is the Fuchs test. Both stretchability and dryability can be assessed. In Fuchs test, both the dryability condition of the sheet metal and the stretchability of the sheet metal can be assessed. Here the both die and the punch are in the form of conical shape. The fixed diameter blank is drawn between die and the punch. The fixed diameter blank is drawn between the die and the punch. The holding pressure on the blank is gradually increased until the edge wrinkling is completely eliminated. Then the cup depth is measured at a maximum load, referred as the formability index. This index is used to assess both the dryability and stretchability. Is the Fuchs test. This test is mainly for to find out the stretchability and the dryability condition of the sheet metal. Here gives the punch, die and blanks conditions. The punch is press against the blank into the die opening. The cup shape is formed. In this holding pressure, the wrinkle edge is completely eliminated. Here the index value of the Fuchs test shows the dryability and stretchability of the sheet metal. And the final test is the full scale forming test. Yes, the full scale forming test. In this test, the forming limit diagram is obtained to describe the different strain condition and their combination with load to failure of the sheet metal. Here is the formability limit diagram. This diagram shows the describe the different strain condition and their combination with load to failure of the sheet metal. in short form, FLD diagram, formability limit diagram. In a full scale forming test, this one is important. FLD diagram, formability limit diagram. Here in this diagram shows the different strain conditions and their combination with load to failure. How much of load, this type of load, how much of strain condition is required and the failure occur. All the things are given in the FLD diagram under the working condition. The strain distribution is assessed from the surface, but the magnitude of strain is determined by impregnation the sheet metal with a rigid pattern or concentric circle followed by the press. Usually the strain distribution is assessed from the surface, we already know, but the magnitude of strain is determined by the impregnation the sheet metal with a rigid pattern or concentric circles followed by the pressing. During the pressing of the sheet metal, concentric circles are stretched into elastic shape. During the pressing of the sheet metal, due to the pressing of the sheet metal, the concentric circles are stretched into the elastic shape. Here the major and the minor axis of the ellipse gives the direction of the principle of the strain. Here is the elliptical shape in the FLD diagram, and here is the diagram. So left side is the tension compression and the right one is the tension to tension. Tension compression deep diagram, tension stretch forming. The elliptical shape shows the different strain condition and their combination with the load and the failure of the sheet metal. Here is the in the right side one, it's a positive value in the FLD diagram. Its left side is the negatives values. This diagram shows the center one is the 0 and right side is the plus 40, plus 80, plus 120. It's the strain values, and left side is the minus 40, minus 80, minus 120. The actual strain on the sheet metal is determined as the strain is equal to a length of the major or minor axis minus corresponding concentric circle dia by corresponding concentric circle dia. In mathematical formula, the strain is equal to L minus D by D. Here L is equal to length of major and minor axis, and the small d is equal to corresponding concentric circle diameter. The graph is plotted between the major and the minor surface strains. In this graph, the left hand side refers strain state in negative, which indicates the combined tension and compression of the deep drawing operation. Here is the left side is the negative of the strain state, which indicates the combined tension and the compression of the deep drawing operations. But in the right side is the minor surface strain values in the positive, which indicates the biaxial tension of the stretching operation. That is the tension and the tension, which means the biaxial tension of stretching operation. Right side is the stretching operations, and the left side of the which diagram is the FLD diagram. The left side of the FLD diagram is the negative one. This shows the tension to the compression of the sheet metal, that gives the deep drawing operations. The right side one is the biaxial tension, that gives the stretch forming operations. Right one is the positive and left one is the negative of strain values. The strain values is depend upon the load condition. Due to the applied punch load against the blank into the die opening, how much of load is given, and the strain rate show the FLD diagram. Here is some of the applications of the FLD diagram. The new sets of tool in easy, hard or impossible to work can be easily determined. Is a new sets of tool. Good material used in forming operations are identified. And the next advantage is the location of the source of trouble is also easy from a reference pressing by the designer. These are up to this. These are all the various types of test in the formability of sheet metal. First of all we see the various types of tests for bulk deformation, and the second one is the elastic plastic deformation. This elastic plastic deformation under the three category of the test. First one is the test based on tensile, and the second thing is the simulative drying test. In the simulative drying test we see Alshan and Ericsson shift Ficky's test, and the final one is the full scale forming test. In this test we are going to see the FLT diagram to understand the better concept. Up to this the various tests in the formability of sheet metal is completed, and the next topic is the formability methods, formability process. Special forming process. The next topic is the forming process. Some of the what is forming process and special forming process. Forming process is done by pressing the form tool over the blank to obtain the required shape. We already know that what is forming. By using the form tool, give the force to the form tool against a blank to give the required shape. The form tool is activated by the hydraulic cylinders using the hydraulic fluid, or by changing the hydraulic cylinder we give the matting die methods. Sheet metal is placed over the lower die and its the end are fixed on the movable grippers. Then the upper die is moved towards the blank. The upper die is activated by any other means of hydraulic fluid or hydraulic forces or pneumatic forces. This is the forming process, the basic forming process operations. Some of the special forming operations are, the types of special forming operations are hydroforming operations, rubber pad forming operations, metal spinning operations, explosive forming operations, magnetic pulse forming operations, pin forming operations, superplastic forming operation, micro forming operations. The next video, in my next video, we are seeing about the types of the special forming processes. Thank you.